dot b of z dot dy, isn't it? Yes.
Yeah.
Minus j hat. That's all there is to it. This is, I call that delta y, is equal to mu naught j 0 over a, I'm above it, z, and then that will be delta y z, that's just dz, isn't it? Between 0 and a. Correct? Work that out, I'll get bz. I'll just get the scalar part of it, obviously, that dots into that. That'll be bz minus, actually. The delta y's cancel on both sides, and I get mu naught j naught over a, and I believe I get a squared over 2, and that is it.
Dr. Snowfall, why do you make, if you're looking for the outside, right? I understand why you make your Amperian loop like past the A part. But then if you're integrating from 0 to A, aren't you cutting it off?
You are, because the current out here is 0.
So why can't
you're you're integrating this. This is more properly done like this. That's the general answer.
Yeah, but RZ is A.
But what? This is j naught greater than 0. This is j greater than 0. What's j here?
So you're only integrating over the area that.
You're only integrating. First of all, physically, you know what you're getting? The total current through the loop.
Yeah. But my question is, why can't I just make my Amperian loop from 0 to A? Like, why do I have to incorporate that j equals 0?
Because you want it outside. You're asked to find it outside.
So I try to make it.
So you just okay. You integrate it, but j is 0. Yeah, the thing you're actually integrating is the current density, right? It's 0 outside of there. Okay, so you get that. And of course, it's a very simple thing. If you want it inside, this guy just becomes, instead of a squared over 2, what do you get? Z squared over 2.
Yeah.
And that's the answer. So inside, B interior would be mu naught j over a, z squared over 2. Did I miss anything? And that's positive, right? On this side, no, on this side it's negative. What happens on that side? Do you have to do this problem again for the bottom?
Yes.
Nope.
Well, you have, they ask for
it.
Well, above and below, what I'm saying is, of course, you have to do it to get the answer, but you have to physically perform it. No, because you know what it is here, you know what it is down there. It's positive here, negative there. Okay? So it's constant, looks like this. It's constant, 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 some negative value till you get to minus a. Then it's an inverted parabola. That's what this thing. That's what it looks like. You saw that, and by the way, you saw. That's the graph of it. You saw that when you did, if you look at the page, you saw this, right? For constant. Let's do the last one that everybody put. Yeah, go ahead, Kevin.
Your Z was absolute volume Z.
Yeah, but since I'm above, right? Since I'm above, Z is positive. And that just shows, here's what the current density looks like. This is Z, okay? Is A to minus A? Or 0 to A? Minus A. Okay, current density, right? Looks like that.
Yeah, that's, yeah.
Okay. I can do one side. If I ask you to integrate this, if I ask you to integrate this function, you go from here to here, what would you multiply by? Okay? You use a symmetry operation in your head, didn't you? If I know this value, I know this value. This argument was to tell me that I don't need to do it twice. This argument here is to tell me if I know what its magnitude is at z, I know what it is at minus z. Okay? It just happens to be in the opposite direction. That's what that. I love this argument. I invented it. Not really, but I kind of did. Kind of did. You're looking at me like I didn't. I'm not going to win this contest. Sterica, you got me beat. All right, let's do the last one. How are we doing on time?
Excellent.
Doing good on time?
I don't know. Have a look.
So Nichols, just so you know, you got three spatial directions. Huh?
Okay.
X, you got your Y,
Okay.
you got your Z. Okay? The way I can orient them, instead of saying point in the X direction, is associate a direction with X called I hat. Okay? So you call it a unit vector. And every time if you have the number 3 I hat, 3 feet I hat, it means go 1 foot, 2 foot, 3 foot in the I hat direction. If I then say go 2 J hat, you would go 1, 2. And if I said then go negative 1 K hat, minus, and that would give you where you were. It's a fancy way of writing down north, south, east, west, up, down.
It's not testable, is it?
It's not what?
It's not testable.
It's testable enough.
Yeah, I'm glad I was a psychology major.
This is 827.
Oh, gee.
Page 301 to 302.
302.
Thank you. We have here a beautiful triangle.
So beautiful.
So beautiful that they gave it a name. It's something.
They said that on Golden Girls last night.
What?
And it was nasty. They were talking. There was 3 old ladies talking about sex, and she was like, "Well, how was the sex?" She was like, "It was so good, we named it." I was like, "What?"
Golden Girls?
They're all. That show is funny. That show is
actually really
funny.
funny.
Great.
It is
Well, apparently
hilarious.
there's also steals his jokes from it, so
You
you
should
know.
watch it.
Yeah.
So
This
funny.
which one was 1, 2, 3? What's this one?
That's one.
No, that was 2.
The Arthur died.
Yeah, that was 1. Never mind. I'm having
afraid I'm gonna have to turn my back on you.
You already had your back turned on me. I don't know why you turned around.
He turned around to be able to turn his back on you.
That was just a waste of energy.
Root 2s, s. So which one was this one?
That was
One.
1.
Which one was this one?
And
3.
And this one was M2, right?
Yes.
What's the first thing they want? I forgot already. The work done. To flip over M3, right? I'm going to do, the reason I do this, even though you have most of it in front of you, is just to show you that maybe this helped you, maybe I did it a different way from the voice of experience, maybe it'll tie some things together. Work done is equal to the change in what? The work done is equal to the change in potential energy, correct? So if he wants to know the work in going from here, you know, this is nothing more than how, you all have bar magnets in your life, right? Put a bar magnet here, put a bar magnet here. He wants to know, they're fun. He wants to know how much it takes to flip that top magnet over. That's what he wants. Flip it over. All of these are identical. So M1 is MK hat. Nope, it's not. It's MJ hat, right?
Yes.
M2 is MJ hat. Look at that. M3, oh for goodness sakes, is MJ hat. So I got them all. So the work done is to change the potential energy. I know what the potential energy. If there was one problem last semester that I said, y'all threw away points for nothing. It was that energetic dipole P dot E term, remember? I don't think anybody got this one all the way through. Then you saw me work it, and what did you all say? Is that it? Is that all there was? You mean I threw away my points for that? Yes, that's what you did. You pissed them away like they were free.
So you're
Okay.
still